Understanding Mohr Circle, Part 1, Passport Problem. Hello, welcome back to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. If you like what you see, please subscribe and don't forget to hit the bell icon so that you'll be notified every time we upload new videos. Okay, in this video, we will be solving a passport exam and I'll be explaining to you about Mohr Circle. How to do, what's the reason, what's the use of the Mohr Circle? Well, I find this very important because I find this in the review. Most students had a hard time solving or understanding this one. So, I will share with you itong topic na to. Na? So, application to sa stress. Na? A state of plane stress. Alright, so the problem that we'll be solving is a past board exam. Okay, some of you are very familiar with this. A rectangular bar 50 mm by 75 mm in cross section is subjected to a tensile force of 220 kilonewtons as shown. Plane AA makes an angle, this plane makes an angle of 25 degrees with the x-axis. Excuse. With the x-axis. All right, the questions are, what is the tensile stress in plane AA? Second, what is the shear stress on, on plane AA? What is the shear stress on plane AA? The tensile, the shear, and at what angle of plane AA is the shear stress maximum? I know for some students this is a very easy problem, no? But I will be doing this as part 1 because we'll be doing this part 2 and we'll be solving, we'll be adding more what ifs, no? So in our succeeding parts. All right. So this is very similar to a board exam. I forgot that year, but this has been coming out several times already in the board exam. Okay, so how will we do this? So we have here the figure. The dimension of the block is 50 mm by 75 mm, subjected to an axial tensile stress. Axial. Bakit ba? Ano yung axial? Ano ba yung axial? When you say axial, the force passes through the axis of the body. Ano yung axis? The axis of a body, the axis of a member is a line joining the centroids of the ends. Alright? If these are the ends, okay, centroid, kaya ito yung axis niya. If the force passes through that, we call it axial load. And it produces axial stress. Alright? I hope that makes sense. Okay, so what we are interested or what is required is the stresses along that plane, that blue colored line. Okay, let us define that clearly. Okay, this one here. So I colored it orange. Orange ba yan? Okay, so there are two ways to do this. First, I will not use Mohr circle first. Let's derive the formula. By the way, this is called uniaxial stress. Uniaxial only because the stress is on one side only, one axis only. Okay? Because we have biaxial, stress here sa Y and then also sa X. Meron din triaxial, meron sa Y, meron sa X, meron din sa Z. Okay? This is uniaxial stress only. This is very easy. There is a formula for this. Alright, so we want to know the stress along this plane, AA. Okay? So, AA, the dimension of the plane is A. Okay, let's derive. Let's say this is A, this is B, and this angle here is theta. Of course, this is also A. Okay? So, this is a right triangle here. This is B. This is a right triangle. So, the length of this inclined area here will be B over cosine. Correct? B over cosine. Because cosine of theta is B over that hypotenuse. So, this length is B divided by cosine theta. Alright? So, this is our P. It's vertical. Okay? Now, to solve the stresses on plane AA, let's resolve P into components parallel and perpendicular to AA. So this is the perpendicular component and this is the parallel component or we call it tangential component, normal component. Normal to AA, tangential to AA. This one is the one causing shear. This is the one causing normal stress. Okay, tensile. In this case, tensile. Of course, if this is angle theta, this is also angle theta here. So, of course, we know that the components are the sides of the right triangle drawn with P as the hypotenuse. So, this vertical or the normal component is P cosine of theta. And this one here is equal to this. This component here is equal to this. And that is P sine theta. I made my cursor big so that you can easily follow where am I pointing. All right, so that's it. Then knowing these components, then we can easily solve the stresses, no? The tensile and shearing stresses. So we will derive the formula. Okay, so this is area AA. So what is that area then? So that area is equal to A times B divided by cosine, di ba? A times this length, B over cosine theta. Okay. Now notice what is AB? What is A times B? Actually, A times B is the cross-sectional area of that rectangle. So we can write that as AX over cosine theta. Okay, why did I put subscript there X? Because that area is the area about this plane, this cutting plane XX, area X, area along plane X. Okay, so area X. Okay, so theta is the angle of the plane with respect to X. Theta is the angle of the plane with respect to X. Do not say angle with the horizontal. It will be misleading. Angle with respect to the X. But later on, I will explain that further. All right, so finally, we can also solve the stress here. So the normal stress on plane AA, sigma A, equals P cosine theta divided by the area. The area is equal to A over cosine theta. This is P cosine theta over AX cosine. Okay, so this cosine will go up. So this becomes P over AX cosine squared of theta. Okay, do you see that? Now, but what is P over AX? What is P over AX? That is the stress at along this X plane, axis sa plane, AX. Let's call that sigma X. Okay? Sigma X. Okay? So I will define what is sigma X. Sigma X is the stress at a plane perpendicular to the applied load. Again, this is only uniaxial load. Okay, I'm talking of uniaxial. The formulas na na-derive natin dito does not apply to biaxial or triaxial. Only uniaxial. What is uniaxial again? That is, ang force natin is only on one axis. There are three axes, right? X, Y, Z. So only along one axis. All right. So P over AX. So we can call that sigma X so that the formula is the normal stress along any plane equals sigma X cosine squared of theta. Okay. Again, do not say, okay, I'll memorize the formula. When you memorize the formula, you make sure that you know all the definitions of these terms that we have derived. Okay, let's define each. What is sigma X? Sigma X is the normal stress on a plane perpendicular to the applied load. So if this is the load, this is the plane perpendicular to that. That is sigma X. Meaning, if the load is horizontal, then your sigma X must be taken about a vertical plane. Correct? Okay. Now, what is theta? Theta is the angle of the plane AA from this axis perpendicular to the applied load. Where you solve your sigma X? Kung saan mo sinolve yung ating normal X perpendicular to the applied load, doon mo i-measure yung theta. Do not say theta is the angle to the horizontal. Kasi bakit? Halimbawa, if this body is made horizontally oriented, no? So your theta will not be from the horizontal. It will now be from the vertical. So the correct understanding or definition of that is the angle, theta is the angle of plane AA from the X plane. And what is the X plane? That is the plane perpendicular to the applied load. The X plane here is the plane perpendicular to the applied load. I hope you got it. Next, your sigma. I mean your tau, shearing stress. So tau will be P, okay, tau, shearing stress will be this force, P sine theta, divided by the area. And the area is, saan yan? AX over cosine theta. All right, this will go up. So this will become P over AX sine cosine. And again, what is P over AX? P over AX is sigma X. So again, that's the formula. Formula. Okay. So the same explanation with this. Okay, the shear stress along a plane from the X equals sigma X sine theta cosine theta. All right, so you will always solve first the sigma along the plane perpendicular to the applied load. That will be your sigma x. Okay, so we are now ready to solve part 1 and part 2. All right, in part 1 and part 2, so let us solve this sigma x first. The stress normal to the applied load. All right, on the area normal to the applied load. So that will be P, let's make it Newton, 220,000 Newton divided by that area, 50 by 75. All right, so that is 58.667 megapascals. Ayos. So we can now solve sigma A. So sigma A is sigma x using this formula, sigma x cosine squared of theta. Your theta is 25 degrees. So sigma x cosine squared of theta, and that is 48.118 MPa. And then your tau x will be sigma x sine cosine. All right. So that will be, just check na lang ha, use your calculators, 22.47. Ayos. Most students asking me, sir, what to use here in our tutorial? You can use any calculator. Anyway, uh, many would say, sir, the functionality may be of the calculator that we'll be using now. Actually, I'll make this clear. As of now, the PRC hasn't, hindi pa nila pinagbawal yung 570 ha. Yung 350EX, those are just additional models from the old list. Ah, that statement came out very late last November exam. All students were talagang nag-worry sila kasi up to days before the board exam, they still have the 570 because PRC did not make it so clear na yung palang binigay nila additional lang. And then after several days before the board exam, nilabas nila yung ano nila, yung tawag diyon, yung shall we say statement nila that is just an additional. So meaning, the 570 is hindi pinagbawal. Doon pa rin. Ha? So this coming board exam, we are just anticipating, no? Although there's no announcement yet, but we're just playing safe. What if kung sabihin nila na bawal lang yung 570? No? Kaya we require our students or we suggest to them to use the 350EX. Okay? Kung hindi nyo pa nakita yung 350EX, I have here an emulator, but this is the EX Plus. But anyway, the look is very similar. Okay, excuse me. Okay, I'm still all right. Here it is. Okay, this is how it looks like. But this is the plus edition. The difference abs in the previous it is option. All right, the basic functions are the same. Okay. Okay, sige, let's continue. Now, part 3. At what angle theta of plane AA is the shear stress maximum? So, that is with P given and with sigma x constant because sigma x is constant. It will not be affected by the plane AA. But notice that if the angle theta changes, if the angle changes, this will change. If this angle changes, this will change. So what angle theta will make the shearing stress greatest? Okay, for some, they know this already, but let's derive. Let's derive for ano lang, information lang. as what I also always said to my student, principle muna kayo, tsaka na lang kayo mag-memorize kung wala nang time. No? Pero may time pa tayo. After pa lang ng review, nagme-memorize na kayo. So what will happen? Tatamarin na kayo. Principle talaga yung importante muna. Okay, and if you know the principle, the memorizing will follow. Hindi mo lang alam mo na pala. Kahit hindi mo siya memorize. Alright, part 3. Okay, so ito yan. So, tau yung minamaximize natin. Tau yung imamaximize natin. Okay, so this is the formula. So, we will differentiate your tau with respect to theta. Differentiate natin yung tau with respect to theta. With sigma x constant. Remember, sigma x is constant. So, we have tau, d tau over d theta, sigma x constant. So, this is product formula, sine, cosine, uv. U dv, sine, negative sign ang derivative ng cosine, plus v du, cosine, derivative of sine is cosine. Alright? This becomes sine squared, that will become cosine squared, negative, opposite. So let's transpose it to the other side. It will become like this. And let's divide both sides by cosine squared theta, and it will become tangent squared theta equals 1, and finally theta equals 45 degrees. Alright. So the plane with maximum shearing stress is at 45 degrees with respect to the principal axis. By the way, I will define this clearly. We call this principal axis. Ano ba yung property ng principal axis? At the principal axis, walang shearing stress. Any axis that has no shearing stress, that is a principal axis. Okay, this axis AA is no longer a principal axis kasi meron na siyang shearing stress. Ito yung axis perpendicular to P, and since there is no shearing stress applied here, wala siyang shearing stress, that's the principal axis. So I will redefine theta. Theta is the angle from the principal axis. Sigma x is the normal stress at the principal axis. Okay, so that's the final definition. Okay. Now, sir, where's the Mohr Circle? No? Niloloko yata kami. Sabi mo sa title mo, Mohr Circle. Okay, now, let us solve this using Mohr Circle. I know, mamaya you will say, mas madali to, sir. We will use na lang that one. Mahirap yung Mohr Circle. But I will tell you why it's important to know Mohr Circle. Alright? This is, okay, ito yung masasabi ko. Kung uniaxial stress lang, I'm into this. Memorize that. Pero paano kung may stress na dito, biaxial na siya? Mahirapan ka na with this one. This cannot be applied anymore. Okay, how do we draw the Mohr circle? Ano yun? Okay, let's go back ha. Binalik ko lang. Ito yung sagot natin ha. Alright. Ayan. Okay, so how to do Mohr circle? How do we start doing or drawing the Mohr circle? By the way, sa board exam, palagi na malabas yung Mohr circle. Now, this is, pero ang madali sa board exam, binibigay niya na yung element. In this topic that we are talking about now, wala, tayo pa yung gagawa. Remember, we will do this from scratch talaga. Okay, to do Mohr circle, let's consider XY lang tayo. Anyway, wala lamang stress sa Z. Let's consider a plane, an XY plane in the body. Ito. Okay, ito. That is the plane, the XY plane. That is inside or anywhere, basta XY plane. That is just a square. That is a very small square. We just make it big. Alright? So, move natin siya. So, ito yung X, ito yung Y. Okay. Now, on that element, ilagay natin yung stresses caused by the forces. Okay, this force P causes a stress of P over AX. Yung sigma X natin kanina. But don't be confused with that X there. Yung kinupit natin kanina na P over area na 75 by 50. So that's 58.667. And that is acting along vertically, along Y. All right? Okay. Then, there is no force here. There is no force causing stress. So there is no stress there. Zero siya. Okay, zero. All right? Now, okay. In general, there is shear. But in this case, there is zero shear. There is no shear stress acting on that plane. Alright? So, but in general, meron yan. So here we'll just put that and we'll put a value 0. So I will repeat. I will talk more about shear later on. For now, wag na lang muna natin i-mix up, baka malito kayo. Alright, ito yung stress on the Y along this direction. And that is P over the area. Ito yun. Since there is no load sa X, then walang stress dito sa part na to. Wala. So, 0 siya. Okay. Next, we will plot these stresses in the sigma tau axis. Sigma along horizontal axis, tau along vertical axis. Alright, so when you plot, you must have points. Now, what points are we going to use? The points must be, of course, sigma tau ang kanyang coordinates. Horizontal, sigma, vertical, tau. Okay, ang ipa-plot natin ito. Now, along this direction, along X, your sigma is 0, your tau is 0. So that is your X. The coordinate is 0, 0. The first is the sigma, the second is the tau. Okay? That is your X. So let's plot that. And that is 0, 0. That will be plotted here. Alright? So this locates your X. 0 ang sigma, 0 din yung tau. Did you get it? Okay? Next, your other point. The other point is here. Okay, this point, sigma is 58.667, tau is 0. So that is the point, and that is point Y. That is point Y, 58.667, 0. Let's locate that. That will be somewhere here. All right, so 58, that is your Y, and this is 58.667. 58.667, get it? All right, now these points locates the diameter. These are the ends of the diameter of the Mohr circle. So your circle is like this. That is your circle. All right. Then, sabihin niyo sa akin, then, what now? Sabi nga, so what? All right. The center of the circle is here. Of course, obviously, that is kalahati ng 58.667, 29.334. Okay, now listen here. We want the stress along plane AA. The plane AA makes an angle of theta 25 degrees from the X. Let's draw that plane here. This is your plane AA, and this is the angle theta, 25 degrees. Now, again, look. Itong plane X now, the point, okay, this plane X is represented by this point. This plane Y is represented by this point. Now, let us locate this plane AA in this circle. And how will you do that? Okay, listen here. Plane AA, this AA plane, is making an angle of theta 25 degrees counterclockwise from the X. Look here. Counterclockwise. Plane AA makes an angle of 25 degrees counterclockwise from X. Remember, counterclockwise from X. So from X, you move counterclockwise also. Counterclockwise, but double the angle. Look here. From X, I will move counterclockwise. So pag ganito. Ito, clockwise ba ito, di ba? Pag ganun. Counterclockwise but double the value. Alright, so look at here. Double the value. All right. So that should be 50 degrees. That's it. This is 50. Doblehin mo yung value niya. Double the value. All right. Now, but this is not your A. Your A is not this one, but your A is on the opposite side. This is your A. All right. The coordinate of that defines the stresses on plane AA. So just like look for the coordinate of that, sigma and tau, then you have the stresses. Okay, let's try. All right, so this is your sigma A already. Sigma A, and this will be your tau A. All right. Okay. Well, of course, to do that, you must be knowledgeable with a little trigo lang naman to. You don't need to memorize the formula here. All right, the radius of the circle is 29.33. So of course, this angle here is equivalent or is equal to that. That's also 50 degrees. Okay, this is 50 degrees, and this is the radius of the circle, which is 29.334. Klaro ba? Kalahati ito yung diameter niya. Na? Okay, so now focusing on this triangle here. Look at this triangle. So sigma AA is this distance plus this distance. Klaro? This R plus this one. So that will be 29.334 plus, how much is this? This is R cosine of 50 degrees. And that will give you 48.19. And that is the same answer here. Gets 48.19. Tama? Okay, I hope you get it. Next, how about your shear? Well, klaro na to. This will be R sine of that angle. Correct? 29.334 sine of 50. And that will give you 22.47, very much equal to this. Right? So that is your answer. Well, I know you will say, sir, madali pa rin yung formula. Yes, I agree. If that is a uniaxial stress, madali yung formula. I don't encourage this. Ha? Kung uniaxial lang. Kung biaxial or triaxial, you cannot use that. Okay? We will have it in part 2 para meron kayong aabangan. No? Ano ba ito, sir? Biribitin pa kami. Para manood kayo. No? Libre na nga ito. Magreklamo pa kayo. Huwag na kayo magreklamo. Joke lang, ha? Okay. Next. Okay. You might ask me, sir, how about this point? Ano to? What's the relevance of that? Okay? Ito I will trivia. Kung ito yung x, di ba? Itong point represents the stress on this axis. On this x, sigma x. No? That's the stress on that. The y represents the stress on this, which is orthogonal with x. Orthogonal meaning 90 degrees. Okay, so similarly, if A represents the stress on this plane, your B here, tawagin kong B yan, that represents the stress on that plane perpendicular to A. Okay? Get it? Okay. So I hope you got this idea. Anyway, kung medyo malabo pa, we will have a follow-up example. Gagawa tayo ng part 2 dito with a different example. Ibang example siya. Para makita nyo talaga. Hindi natin to tatantanan. Para makuha nyo. This is one of the problems na palaging lumalabas sa exam. Maraming nalilito. Pero you know what? In the board exam, what is much easier, kasi sa board exam, ibibigay niya na yung Mohr Circle, pinapahanap niya yung stresses, or vice versa, bigay niya yung element, draw mo yung Mohr Circle to find the necessary stresses. Okay? So we will discuss that next time. By the way, may nakalimutan ako. The points represented by this diameter horizontally, these points here, these are the principal axes, the x and the y. Those are the principal axes. So, yun. So, this AA is not a principal axis, kaya meron siyang shear. Okay? Ano ba nakalimutan ko dito? Anyway, kung meron man, I will present that on the next video. Okay? Tapos, may nagtanong sa akin, sir, ano tong line na to? Wala, nagkamali lang yan. Okay? So, thank you so much for watching, and hope hindi kayo magsawang magsubaybay sa ating channel. This is free. All you have to do is subscribe and share this to your classmates, to your friends na civil din, or even any engineering that will use these topics. Okay? So, hope you will subscribe, and para ma-updated kayo sa click the bell icon para ma-updated kayo sa mga panibagong videos namin. Thank you so much for watching.